From the mountains to the desert, a monumental gamble begins as America seeks power, water, and work all in one bold project. In the early 1900s, the Southwest faced unpredictable Colorado River floods that could devastate growing cities and farms. Then the Great Depression hit, and a single project promised jobs, hope, and a future. Congress approved Hoover Dam in 1928, a plan to control the river, store water, and generate electricity. Enter Frank Crowe, known as Hurry Up Crowe, the chief engineer who pushed the work forward relentlessly. The site was Black Canyon on the Nevada-Arizona border, where the river would soon be tamed. Before any building could begin, the river had to be diverted away from the future dam. 4 massive diversion tunnels, each 56 feet wide and over 4,000 feet long, were blasted into the canyon walls. Cofferdams blocked the river's path while workers rerouted the flow to dry the construction site. With the river diverted, the dry site could finally begin the dam itself. Hoover Dam is an arch-gravity design, using both weight and a curved shape to press water into the canyon walls. This design was ideal for a narrow canyon like Black Canyon, redirecting pressure efficiently. As construction continued, Lake Mead began to form, the largest reservoir in the United States. The project required more than 3 million cubic yards of concrete, enough to span a highway across the nation. Pouring all at once would take too long to cool, so the engineers poured block by block. Each block measured 20 by 20 by 10 feet, allowing independent cooling and curing. Embedded inside every block were networks of thin steel pipes carrying chilled water from an on-site refrigeration plant. Ice rods, a frozen form of water, were placed inside the wet concrete to pull heat away and speed cooling. When each block cured, the pipes remained, filled with grout to seal and strengthen the structure. Thousands of blocks joined together created a monolith meant to last centuries. A system of rail lines and cableways ferried buckets of concrete across the canyon with startling precision. At the base, a powerhouse took shape to turn flowing water into electricity. Water from Lake Mead flowed through massive penstocks to drive the dam's 17 turbines. The result was electricity for millions, powering cities like Los Angeles, Las Vegas, and Phoenix. Before Hoover Dam, the Southwest was dry, flood-prone, and unpredictable. After, growth and irrigation flourished. The dam did more than hold back water. It spurred a regional boom in industry, irrigation, and jobs. Over 100 men died building this seemingly impossible project but got the job done. But today, a new crisis threatens the dam. Climate change and a mega drought in the Southwest. Lake Mead has fallen to record lows, limiting water supply and reducing hydropower potential. Engineers are responding with more efficient turbines and exploring new water intake depths. Solar and wind are increasingly used to supplement hydropower in a diversified energy mix. The Hoover Dam remains a 20th century miracle, but the 21st century will decide its fate. The dam's legacy is not just concrete, but the way it shaped a region's destiny. If the water runs dry, the future of the dam becomes a question of adaptation and resilience. The legend of Hurry Up Crowe and the thousands of workers looms as a reminder of human endurance. This is the story of how a colossal gamble became a benchmark of American engineering. And it poses the question, what will it take to keep the dam alive in a warming world? The answer lies in innovation, partnership, and steadfast long-term planning. This is the story of the Hoover Dam, America's greatest engineering gamble.